phone to ask a question or make a comment, we won't be able to hear you. So, so everybody is muted as of now. There is a way to ask questions, and we'll get to that in a minute. Second, this is the second webinar that we've held. The first one was back in December. The first one was titled Product Solutions Through Die Casting. And for those joining us again, welcome back. Thanks for attending this one. If you missed the first webinar that we held, it is on our website. We recorded it, and the entire thing is on our website. We'll give you some details about how to access that toward the end of this presentation. There also, at the end, after the presentation is over, you'll be getting a follow-up email with some additional links and other information. And also, you'll get a questionnaire and survey. And if you would take a minute just to fill that out, that really helps us try to tailor future webinars and find out what content is important to everybody, and it would really help us. So I appreciate you doing that. There we go. Again, this is me. My name is Jody Schollard. I'm the sales manager for the Southeast U.S. So anybody joining us from the sunny Southeast today, you may see me coming through your building if we have a meeting. Been with Chicago White Metal just over 5 years, and in the die cast industry for 8. We have a team of panelists also on the line, and John Miller, Mike Dimitrov, and Tom Rock. They are available to answer your questions. And speaking of that, to do that, if you'll look at the right-hand portion of your menu bar for the webinar, at the bottom you'll see a box that says questions. So if you will just type in your question there and hit send, we will do our best to get you some real-time answers to your questions. In addition, what I'll do is I'll be kind of monitoring what questions come in, and if there looks like to be a common theme to some questions, I'll try to answer a couple as we go along. So the agenda for today, based on the last webinar that we had back in December, common theme after the webinar was over was that a lot of people would like some more information on how to, what types of surface finishes are available for die casting. So that's the goal of today's agenda. What we'll look at is some factors to consider when selecting a finish. What are some of the finish options available? We won't obviously go over everything. This will take a week probably to go over all the finishes that are out there, but we'll talk about some of the more common ones that we use on a regular basis, and different types. You can see a comparison of them. We'll look at some of how the part design features might affect the resulting finish of the part. We'll look at some potential quality issues that result from the various finish options that are out there. And we'll talk about how Chicago White Metal can help. If there's questions and concerns about a type of finish or what might be suitable for your application, please let us know, and we'll do our best to help walk you through the best option. Some of the factors to consider when looking at a finish for a die casting. We have a little catchphrase up there, start with the finish in mind. And yes, that is a little cheesy, but it is accurate. It's best if we know as much about the finish requirements of a part at the beginning of a project as we can. Many times we'll get into a project and the finish requirements will get pushed out, and by the time you're tooled up and ready to go, then some requirements come in, and well, maybe there's a gate where you wanted a high quality surface, and so that is hard to work around when the tool's already built and you're already making parts. So as much as we know and can work with you ahead of time, that it helps the end product just that much more. So what are the factors to consider? Cosmetic appearance. Is there a specific look that you're trying to achieve with your part? Is there a color? Is there a texture? Is there what kind of appearance are you looking for? Part ergonomics. Is there a touch factor to your part? Do you need fingerprint resistant coating? Do you need a certain amount of texture with your coating? That's another factor to consider. Are there specific corrosion requirements for your application? As we go along through here, die castings as cast have a certain amount of corrosion protection. And maybe that is great for some people's applications, but other ones need a higher level or maybe a super high level of corrosion resistance. So if you know what your requirements are, let us know, and we can help steer you in a direction or another. Is there electromagnetic interference or RFI shielding requirements for your application? There are different coating options, finish options that help with that. Is your part require a pressure tightness? Is it used as a pressure vessel or going to have a leak test requirement to it? Again, that's something to consider and let your die caster know as much of that as you can. Is your requirement to be conductive or non-conductive? Is your part going to be a heat sink and you want a coating that's going to be conductive so that the heat transfers away? That's another thing to consider. And of course, the project target price. All the options that we talk about today have a varying price to them. So let us know. Obviously nobody can say, here's a blank check, go do what you want, but when you look at the different options that are available, and we'll try to give you at least a guideline of comparable price, keep that in mind and see what might fit your application. Here is just a sampling of the finishes that are available. We try to break it down into categories. So we have a mechanical category where parts are vibratory deburred or shot blast or ball burnish, that type of thing, and we'll cover through most of those. Chemical conversion coating, where parts are put in a plating bath and the surface of the die casting is actually converted. The alloy and the chemical composition of the surface is converted to make an anodized part or a trivalent clear chromate, that type of thing. We'll talk about those. And what we call final coatings, things that typically we would consider to be a highly cosmetic look, from powder coats to wet paint, all the way through. We don't talk about all these that are listed here. We just wanted to give a sampling of what is out there. And again, there's many, many more. So what we did for this presentation, we thought it might be a good idea in order to compare finish to finish a little more accurately, we took a sample part, and this is a picture of it on the screen. It's a small aluminum part, 2.5 inches by about 2 1/4 inches by 3/4 inches deep or tall. And we use this part throughout the presentation. So the varying coatings that we talk about and show samples of, this is the part that we used. And we did that to try to make it a little more easy to compare plating to plating or coating to coating. And visually, the comparison will be easier. And also the cost. It's a relatively small part, but you can at least see the comparison between the cost of the finishes. One other thing to note is we based all of our pricing in this presentation based on a 500-piece lot size. So you'll see in here where there's times where we'll say with setup, cost with setup. So a larger lot size might end up reducing the overall cost per part, but we try to keep it consistent. So a 500-piece lot size was used in the pricing for all the examples that are coming up. So the first section we'll talk about mechanical finishes. And again, that covers shot blasting, ceramic media, plastic media, ball burnishing, glass bead blasting basically, and polish and grinding. All these coatings, one of the benefits is that it removes the majority of the flash that's from an as-cast part. All of these do a great job at that. They also remove any surface imperfections of the casting. So flow marks and swirls that might visually not be what you want, these will even out the surface and give it a better surface appearance. These also do a good job of good preparation for some of the following coatings that are going to go on. So if the part's going to get a wet paint or a powder coat as a final coating, shot blasting or some of the other vibratory deburring operations do a good job of prepping the surface, roughing the surface up a little bit so that the final coating adheres better. So here's the first example of a type of mechanical finish, shot blasting. The part pictured here was actually performed in the wheelabrate process, which is should be familiar to a lot of people. It was done with a steel shot, and because this part was aluminum, we can do that. We wouldn't recommend steel shot for magnesium or zinc alloys, but this is what we did for aluminum. So we would consider this a finish or a mechanical finish for a non-cosmetic part. It's going to give a nice, even, uniform coverage at a low cost, but we would not consider this a really highly cosmetic look. It does help cover imperfections in the surface that I mentioned. Potentially, depending on how aggressive the shot is to the part, you may have scratching or blistering that occurs during the process, so it's something to keep in mind, and your die caster should help control that. The steel shot is, like I said, relatively aggressive to the part, so any really tight tolerance features, you may have some issues keeping that tolerance after the process, so that's something to keep in mind. And there are various media available. Again, the example that we show here that we had processed was with the steel shot for the aluminum part, but there are different media options available that will allow us to process magnesium or zinc as well. And this cost for this process, for this part at a 500-piece batch size, was 8 cents. That's with the steel media. So that's the bottom line. That's the baseline that we start with. Ceramic media. This is a vibratory deburr process where parts are put in bulk into a tub or a large bowl and then vibrated. And the interaction between the media and the part is what creates the surface. The ceramic provides for a smooth, fine finish. Again, it's a very good base for plating or coatings that come later. And the ceramic, just like the previous slide, can be aggressive to fragile features, so it's something to keep in mind. This can be done with all 3 alloy types, aluminum, mag, and zinc, and at about a 12-cent cost. The next one we show is plastic media. This is done in the same process, but the media used here is small plastic. The media comes in different sizes and shapes, so you could have balls, you could have cylinders, triangles. It varies depending on the type of finish that you look. Each type gives a different look. This provides a dull, smooth finish. The plastic media is not very aggressive to the part, so it is suitable for fragile features, as well as magnesium. Magnesium need to be a little more gentle with, so plastic is good for that. And because it's not as aggressive, there is limited edge break. So some of the edges and features of the part that you might require a more significant edge break to, plastic media will not give that. So just something to keep in mind. Again, all 3 alloy options are available to be processed this way, and again, at a 12-cent cost. Ball burnishing is a very low-budget option for a nice mirror shine. In this process, the metal was actually being worked, basically, to get the desired appearance. It definitely helps remove burrs of the part. It does have the highest cost media. There's stainless steel media that's used in this, and it is a high-cost media. Again, all 3 alloy types, and this cost is 30 cents. Glass bead is another shot blasting type of process. Provides a very smooth, uniform finish. It's a good base for final coatings that come. It is more of a manual process. Many times this is done part by part, so the labor content is slightly higher. You will have, because of that, you will have some varied part-to-part matching issues potentially. Part to part and lot to lot. So next time you run it, it may not look exactly like it did before. And one of the reasons is the media wears very rapidly. So depending on if it's new media or old media or where it is in the cycle, the look will come out a little different. All 3 alloy options are available with this process, and we call this a medium cost. The previous ones were all in our low category. This is the first one for a medium, 35 cents. Polished parting line, if you look at the image, this is actually the same part. The part below, mouse marks, here we go. You can see on this part a rough edge to the part in this area. What that is the gate vestige that is left over after a part is cast and then die trimmed. You'll have a rough edge where the gate metal flowed into the part, or overflows, or other types of tooling configurations where metal comes in or out of the part. For a lot of people, the as trimmed look is fine. It's not a problem. If it's a highly cosmetic finish, many times that's not acceptable. Even if you powder coat or wet paint on top of this, the rough area will still show through. It's not like it'll cover up with powder coat or wet paint. It'll still show. So what we do is, again, this is a more manual process, but we will actually polish the parting line, and the result of that is what's above. The above image shows what happens when you remove that gate vestige, and it once a powder or wet paint or another cosmetic finish gets applied to that, it looks fantastic. You could never tell that there was a gate or any other tooling remnant visible. And again, we would consider for cosmetic parts. The only concern potentially to look out for is maybe over polishing and rounding some features. So if you need a nice straight edge all the way through, just something to consider that you don't want to over polish. Again, all three alloy types are suitable for this, and at a 42-cent relative cost. We'll now look at some chemical finishes. This is the second category that we looked at. The types that we'll cover today are trivalent clear chromate, yellow chromate, anodize, and a non-chrome yellow. If you see the picture, all these processes or all these options are processed in a tank. The parts are either rack plated or potentially bulk plated or bulk processed in a basket and then hung on the racks, which you can sort of make out on the image, and then put through a variety of different baths to achieve the final the coating that we're trying to do here. In all of these, like I mentioned before, the chemical makeup of the surface of the die casting is actually being changed. So one of the benefits of these coatings is that there's really no added thickness to the part. So parts with complex features or tight tolerances, there's basically zero added thickness, and so it's a good side effect for this type of finishes. All these finishes provide additional corrosion resistance over a raw casting. They also, like the previous batch of options, provide a proper surface preparation for following for any coatings that come after it. Again, we would consider this not a cosmetic finish, but can be used as a final coating if that's all that's required. Many of our customers do use these options as a final finish. The first option that we look at is a trivalent clear chromate. It has a dull gray appearance, can have a bluish tint at times. It's very inconsistent from batch to batch exactly how the parts come out and look. It does provide excellent coating adhesion for the following finishes that might be applied to this part. The two things to consider when looking at pretty much all of these bath-plated processes are chromate entrapment, and a white powdery residue that can be an issue with if the part has blind holes. You can imagine if a part is racked and then lowered into a bath, sometimes blind holes have a hard time receiving the liquid into them, and then a hard time getting that liquid back out. So it's just something to consider. Proper rinsing of the parts after the process will typically alleviate that, but just something to consider. Again, all three alloy options are available for this Trivalent clear chromate. Provides medium corrosion resistance. So this is a relative scale on top of the corrosion resistance that an as-cast part has. So this provides an extra layer, and we would call that a medium corrosion resistance. The cost of this is about 44 cents per part in this process. Does not add any wear resistance to the casting, and it is RoHS compliant, which is I know important for many of our customers when looking at reduction of hazardous substances. This complies with that. The next one we'll look at is a yellow chromate. Again, processed very similar way. This again varies in color from part to part, batch to batch. We say yellow chromate, but sometimes you would be hard-pressed to call it yellow. It does improve the adhesion of final finish, and the two blind hole issues that we talked about with the previous slide applies to this as well. Again, all three alloy options, medium corrosion resistance, 44-cent cost, and this one is not RoHS compliant. So this is one to keep in mind with that. If we look at anodizing for die casting, provides a very low gloss, sometimes matte finish to it. Comes in clear or black when looking at processing for a die casting. A very non-uniform finish. We would not consider this a cosmetic look. It is very good for tight tolerances because of the minimal thickness applied. It is non-conductive type of plating, and again, low film thickness. The options that are available for this are aluminum and magnesium. We don't anodize zinc. It offers a medium level of corrosion resistance. 47-cent cost. Does provide some extra wear resistance, so we call that medium, and it is RoHS compliant. There are typically some sealers that are applied to anodizing as a follow-up process. Some of those are not RoHS compliant, so those are things to keep in mind. You just want to make sure that the sealer that's being used either is or is not versus what you're looking for. I'm looking at the questions, and it looks like there's a few questions that are coming in about why anodizing on die castings did not look like the anodizing on a machine 6061. That's a very good question. We get that a lot. A lot of people are used to seeing anodizing on machine parts with 6061 or extruded parts, and the finish of an anodized part looking great. So it's nice, shiny, consistent, uniform finish. And then when they see an anodized die casting, it looks nothing like it. What happens is in the other processes I mentioned, extrusion and 6061 machining or other alloys and machining, those are almost 100% aluminum alloys. The die cast alloy that's being used, 380, 383, 390, 360, all of those, has enough other alloys in or enough other chemicals in the alloy to prevent the nice shiny finish that you get with an anodize, especially the presence of silicon. That actually is what's preventing the nice consistent finish. So that's kind of the answer to that. We wish there was a way to make an anodized die casting look the same, but unfortunately there's just not. There are different types of anodize. We cover that a little bit in the slide coming up that provide a much higher level of wear resistance and corrosion resistance. The cost of that goes up, but there are different options for the anodizing. The last one in this section is non-chrome yellow. It gives a light gray or yellow appearance. It can look mottled at times. Again, good for paint adhesion, and the two same concerns with blind holes are in effect for this option as well. All three alloy types are available. Again, medium corrosion resistance, and we would consider this more on the high side of especially of this category of finish at 93 cents each. Provides a low level of wear resistance, and it is RoHS compliant. This slide just gives a summary of the 3 types of chromates. We don't have Anodize in here, but it does show visually the differences between the 3. It's a little hard to see some of the differences, but you can see the varying shades of appearance that you'll get. Okay, we'll look at the third category of finishes that we talk about, which is coatings or the final coatings, however you want to say it. These are the options that we'll look at: E-coat, copper tin plate, varying types of powder coating, Electroless Nickel, and liquid or wet paint. These are what we would consider cosmetic coatings. So these are going to give the very high level of cosmetic look to the part. E-coat is the first one we'll talk about. It provides a black glossy finish. Black is overwhelming. The overwhelming choice of color for this. There are some other colors that are out there being developed for die casting, but they're used very, very little. So 99.9% of the time, you get a black part if you want to E-coat. But it does provide a very consistent thickness at 1/1000th or a little under 1/1000th of an inch. Very good for complex designs and part features. This is an insulating finish, so if you're looking for a finish to go on a heat sink or something else, this is probably not what you're going to want, because it would not allow the heat to escape. The one concern for E-coating, or one of the major concerns, is air pockets. Again, this is done in a bath process, so there is a potential for air pockets to be entrapped underneath the E-coat finish. This process is good for all 3 alloy types, aluminum, mag, and zinc. Provides a very high level of corrosion resistance. Medium cost at 44 cents. Medium level of wear resistance, and it is RoHS compliant. The next option we'll look at is the copper tin plating. Provides a high glossy finish, and it is solderable. So if it's an application where you maybe have an electrical connector or something else that needs soldering to other parts, this is a very good option for it. Provides a very uniform finish. Again, good for tight tolerance features. It's a very, very, very thin layer of thickness that goes onto this. This is a conductive coating, and it does provide for very good EMI shielding. So if you have a few parts that are going to act as a device for electronics, this is a good option for protecting the electronics from EMI shielding. We look at aluminum and zinc for this alloy, or for this plating type, not magnesium. Provides a medium level of corrosion resistance, medium level of cost at 70 cents, good wear resistance, and it is, again, RoHS compliant. Powder coating, that's a very common final finish that we get into with many of our customers. You can see the 2 images of smooth and fine texture. So these are both powder coats that are shown there, come in a variety of textures. Again, we would consider this a final finish for very cosmetic parts. Very long-lasting and durable option for a finish. Comes in a wide variety of stock colors that a powder coat house might have. You can also do custom colors. With a little time and money, you can develop a custom color to fit another color chip that you have, or matching another part in your assembly, or something like that. So you can develop custom colors. Uniformity of thickness is a little difficult to maintain. These parts, the way they're processed is that the parts are hung on a rack, and then the rack and parts are electronically charged, and that is what attracts the paint when it is applied, or the powder when it's applied. So depending on the part configuration, if you have deep features or tall features, you may have a bit inconsistent amount of thickness depending on the type of feature. Parts after they come out of the spray booth are heated to cure. And again, so all three options are available for this, aluminum, mag, and zinc. A high level of corrosion resistance, a medium cost of 80 cents, and again, we show with setup. So this was, when you look at a 500-piece lot size, there is some setup charge that's included in that, which drives that medium 80-cent price up a little bit. If you had 1,000 pieces or 5,000 pieces, that cost potentially could go down. Very high level of wear resistance with the powder coats, and again, it is RoHS compliant. One of the concerns to look for, or to just keep in mind with any type of powder coating or wet paint that's going to be applied, the parts are, like I said, racked on during the process. So you have to be cognizant that there is going to be a rack mark remaining behind, and that's just something we want to bring up and make sure you talk about with the die caster is, a potential good position for that rack mark. A couple of other quality concerns to look out for when doing powder coating: outgassing on the left. I see a couple of other questions that have come in during the presentation started about what is outgassing, how can it be controlled. Outgassing is due to entrapped subsurface air that escapes during the heating and curing process. Something we take into account many times during the tool design. We'll look to see if there's ways to minimize porosity or move porosity from one location of a part to another away from cosmetic areas. So if you know a certain surface must have a very nice cosmetic finish, and our analysis ahead of tool design shows that there might be some potential for porosity in that area, then that's something we'll take into account and maybe redesign the tool or do some things to try to minimize that. Another thing that will help alleviate the outgassing is preheating the parts at the powder coater prior to being processed. That will typically control the amount of outgassing that occurs, and again, something to talk over with your die caster about. Another thing that is common is an orange peeling condition. You see the image on the right shows a nice smooth part above, and then the orange peel, or it almost feels like a texturing. And what that is it's an over thickness of powder that's applied. This occurs many times when you're trying to apply powder to a deep recessed area in a part, and the parts above, or the features above, will get more coating because of that. So again, it's just something to think about in advance. By changing the way parts are going to be racked and that type of thing, you can minimize this. The next option we look at is Electroless Nickel. It provides a dull matte finish with a very high wear resistance, has a very uniform plating, and is good for very complex features and complex design parts. Again, has excellent EMI shielding capabilities. It may tarnish or darken over time, which is something to just be aware of, but is a very nice finish. Is used on all three alloy types, medium corrosion resistance, higher end of the cost range of the parts or the process that we look at 82 cents, a high level of wear resistance, and again, it is RoHS compliant. If we look at the wet paint, again, what we would consider a finish for highly cosmetic parts, comes in a smooth or textured option. As you can see in the picture, that's a textured look with a wet paint. I know it almost looks like a powder-coated part, but it is a textured wet paint. It cures with lower amounts of heat. So outgassing with wet paint is not nearly as much of a concern. Has UV light resistance capability. Has greater batch-to-batch matching and lower film thickness than the powder coating. Does come in all three, or processed on all three alloy types. Medium level of corrosion resistance. Again, the same caveat with the cost. The setup charges were factored into this with a 500-piece batch size. Medium amount of wear resistance, and again, is RoHS compliant. A couple of the paint issues to bring up, to look out for: blistering and dust below surface. Those are typically caused by improper cleanliness of the part prior to the paint being applied. So that's just something to keep in mind, and work with a house that knows what they're doing as far as surface preparation and getting the part ready to be painted. Sagging typically occurs because, again, too much paint is being applied, or the part is being racked in a certain way that you'll have some sagging, what we call it, of the paint. This chart gives a summary of what we just talked about. So it breaks down all of the different options we looked at, the mechanical, chemical, and coating options, and the relative cost. So this slide will be provided in a link following the webinar, so you can have a relative indication of costs for each. We'll also provide this chart, which is the same information, just in graphical form. The next chart that we will send a link to, this highlights some additional finish types that we use, maybe specifically for magnesium, because our sample part that we used previously in the other slides was aluminum. We didn't get into the Dow 7, Dow 9, NH35 different finishes that are specific to mag. So we wanted to give a little bit of information about those, as well as some other types. Some of these we did cover, but some we did not. So this chart, again, will be provided to you. It does give some indication of the number of salt spray hours that you can expect, whether or not it's RoHS compliant, and the type of alloy that it's good for. If you look on the different finishes down below, I mentioned the various types of anodizing, so we give a couple of other ones here. And again, we'll at the end, we'll provide the information. If we look at how the part design might affect the final finish, we'll look at some features that to take into account when looking at your final finish. Deep recessed holes, which we talked about some before, we'll look at again. Tall exposed features, how a flat surface looks versus versus a rounded surface. For cosmetic concerns, tight tolerance features, masking, and rack points, which we've also talked about before. The tall exposed features that we show here, this is a mounting boss that is relatively tall versus the floor of the part, if you will. As I mentioned on some of the types of options that we talked about, the powder coating and the other options that are where the part is hung and then electrically charged, what happens is taller features almost act like a lightning rod. So it will attract a larger amount of powder or other type of finish to taller features. So that's just something to keep in mind, and potentially, if it's a feature that can't get an over, a higher level of finish, then we might have to mask it or some other take into account because of that. And again, masking is the second point that we highlight. That is something to definitely keep in mind with features that you don't want any paint on, or have a tight tolerance that's tight enough where you can't accept a thousandths or 2,000ths amount of coating, or whatever the case may be. So we'll mask that feature or that area of the part. Many times, electrical connector areas, or areas that you have a O-ring, or something else that you need to have a nice tight tolerance area that will mask off prior to powder coat or wet paint or that type of thing. Deep recessed holes we talk about, especially on any of the options that are bath processed. It is sometimes tough to get the liquid in and out of a deep recessed hole. That's something to consider. The flat cosmetic surface versus curved, we point this out just to show that there is going to be a difference with the same coating if you have a flat surface versus a curved. Visually, the look is different, and it's just something to keep in mind. The texture in a die-cast mold is the bottom right image. If you can see the bottom portions of all these areas of the part, you can see a texture in there. That texture was actually placed in the tool itself. So if you know that there are certain areas of a part you want texturing and other parts that you don't, depending on the part design and geometry, it might make sense to do the texturing in the tool itself. That way it comes out on every part. You don't have to worry about masking the part later to get the desired texture of certain areas and not other areas. So it's something that is an option and to keep in mind. The tool design, how a die-cast tool is designed and the resulting finish, we don't talk a lot about here, but it is something to keep in mind. There are things we can do ahead of time in tool design that will affect the part finish. I mentioned in-tool texturing a part on the previous slide, so that is something to keep in mind. What Chicago White Metal does is utilize a MagnaSoft flow simulation. We talk a lot about this in the previous webinar that was done in December. That webinar is actually, I don't know if I mentioned, is on our website, which we'll give a link to at the end. So if you missed that webinar, you can go back and see it again. But that MagnaSoft analysis allows us to do several things to try to control some potential issues that could take place with the final finish. So porosity, outgassing, whether or not it's a pressure tight requirement part. Those things, if we know ahead of time, we'll try to take into account during our analysis and design the tool to accommodate it. Also, any areas of the part that we might want to gate away from or have no ejector pin locations on. If we know ahead of time certain areas of the part that you need free from those features of the tool, then we'll try to accommodate it. The last bullet point on here is optimizing casting machine size. What we want to stress here is just you want to make sure that the die-cast machine is sized right for the application. If the machine tonnage is just barely large enough for a specific part, the resulting part surface may not look as cosmetically attractive as when a larger machine is used. If you can think about, you want to make sure the tonnage is sized correctly so you can shove enough material and enough pressure to fill the part correctly. And if you're just on the borderline of machine size and part size, the resulting finish of the surface might not look like what you want. So how can Chicago White Metal help? We've been in business 75 years this year, since 1937. We've got a cast of in-house experts on finishing, as well as vendors that we've developed across the coast or across the states. They've been with us, many of them, for decades to provide a variety of different options that you might need. We also have a finishing library in-house, including coupons of the various options, and we'll talk about the coupons in a second. But we have samples and coupons of the majority of the coatings that we talked about today, as well as many, many others. So if you have something that you want to take a look at before making your mind up, just let us know and we'll try to get you what you need. And we've worked on some of the most highly cosmetic projects in the industry. Again, we've done this for 75 years. We'd never say that we've seen everything, but I think we've seen a lot. So we please let us know if there's a way we can help. The sample coupons I talked about. Many years ago, we realized that some of the sampling that was done or chips that are available of different finish options were always done on steel chips or something else other than a die casting. So when a customer finally got their real die casting in production, and it didn't look the same. So we decided we would build a die ourselves that we could run all 3 alloy types in and make these standardized sized coupons. And we send them out. We get various coatings and textures and different finishes applied to them, so we can see exactly how they're going to look on a die casting. And it's really a great thing to have, because you do see differences from alloy type to alloy type. You see differences from if you're trying to do this on a machine part versus die casting. It's great to have the real life die cast part available. Like I mentioned, we have a stock of some of the finishes available now, a wide variety of them. If there's a specific finish that you might want to see, let us know. We potentially can have some coupons sent out and made in that. So just let us know, what you might need. If there's something that you're looking at that you'd like a coupon for, let us know. The follow-up email that will come after the webinar will have details on who to contact for the various coupons. Some additional information that will be coming out. I made reference to these as we went through. Some of the surface finish guides, the various plating comparison charts that we looked at of cost and the different options, and also the information on the coupon request if you'd need some coupons. Also, we would invite you to visit the Chicago White Metal Design Center, which is on our website. We have over 70 die-cast technical articles. Some are finish related, some are other topics about die casting, but it is a very nice library of articles to search from. We also have an alloy selection guide, and as I mentioned, there's a link to the webinar that we did back in December, the product solutions through die casting. And if you weren't able to attend that webinar, I would invite you to go and take a look. It provides more information about general die cast topics, tooling, and how the parts are processed, that type of thing. But it is on our website. And as I mentioned, after the webinar is over, you will be getting an email with all this information, and we'll also have a survey on there. And if you would please fill it out, that would help us learn from this webinar and try to decide what topics are suitable for future webinars. Again, this is my contact information. This will also be on the email that comes out shortly. But we wanted to go ahead and throw this up in case you wanted to write it down and contact me about a specific question or a topic that wasn't covered or anything. So that concludes our webinar for today. Hopefully you gained some insight on the different finishes that are available for die castings. Again, please visit our website or contact us if you need anything else. We'd be happy to help you in any way we can. Thank you very much.